Do you think trigonometry is hard or confusing? Today we are going to break it down in a very easy way. In this video, we see basic trigonometry for class 10, trigonometric ratios, ratios of some special angles, ratios of complementary angles, and key trigonometric identities. By the end of this video, this topic may not seem scary anymore. So get ready and now we begin. What is trigonometry? Trigonometry is a branch of mathematics that studies relationship between angles and side of triangles. It is derived from Greek word trigon, which means triangle, and metron, which means measure. It mostly deals with right angled triangles and used to calculate unknown sides or angles. Now the question is, why do we need trigonometry? We use trigonometry in our daily life. For example, we use trigonometry in architecture and construction for measuring heights of buildings and bridges, in astronomy for finding distances of stars and planets, in navigation for and GPS system, engineering and physics, computer graphics and video games. Now let's start the topic. First we have trigonometric ratio with angle theta. First we have to consider a right angled triangle with angle theta. The side opposite to angle theta is called opposite or height, and side adjacent to theta is called adjacent or base. With this opposite, adjacent and hypotenuse, we get 6 trigonometric ratios. First we have sin theta, which is opposite by hypotenuse, cos theta, which is adjacent by hypotenuse, tan theta, which is opposite by adjacent. If we can find sin theta, cos theta, tan theta, then there exists reciprocal of these ratios. The reciprocal of tan theta is cot theta, which is adjacent by opposite. Reciprocal of cos theta is sec theta, which is hypotenuse by adjacent, and reciprocal of sin theta is cosec theta, which is hypotenuse by opposite. Now we are getting some relation between these trigonometric ratios. For example, as cosec theta is reciprocal of sin theta, we can write cosec theta as 1 by sin theta and sin theta as 1 by cosec theta. Similarly, sec theta as 1 by cos theta as 1 by sec theta, cot theta as 1 by tan theta, and tan theta as 1 by cot theta. We can write tan theta as sin theta by cos theta, as sin theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse. If we divide sin theta by cos theta, hypotenuse will cancel out and we will get opposite by adjacent, which is tan theta, and cot theta is reciprocal of tan theta, that's why it is cos theta by sin theta. These relations are very important. And next we have ratios at certain angles. First angle we are given is 45 degree. For deriving angle at 45 degree, we have to take a right angle isosceles triangle. So in this S side will be A, so the longest side, hypotenuse, will be A root 2. In this way we can derive sin 45 degree as 1 by root 2. Since here adjacent and opposite are equal, so cos 45 degree and sin 45 degree will be equal. Since tan theta is sin theta by cos theta and sin theta equals to cos theta, so the ratio becomes 1. So tan 45 degree is 1. Next we have ratios at 30 degree and 60 degree. For deriving these ratios, we have to start with an equilateral triangle with side A. Now we have to draw a perpendicular bisector from top vertex to BC. We are getting two right angle triangles with angle B as 60 degree and angle BAD as 30 degree. BD is A by 2, which is half of A. So we get height AD equals to root of 3 by 2A. Here sine 60 degree, for sine 60 degree the ratio is AD by AB, and for cos 30 degree the ratio is also AD by AB. So cos 30 degree is equals to sine 60 degree is equals to root of 3 by 2. Similarly, for sine 30 degree it will be BD by AB, and for cos 60 degree it will be also BD by AB. So sine 30 degree equals to cos 60 degree is equals to 1 by 2. Similarly, tan 30 degree also equals to cos 60 degree, which is root 2, and tan 60 degree equals to cot 30 degree, which is 1 by root 2. Now we have trigonometric ratios at 0 degree and 90 degree using a circle with radius 1 centimeter. First we have to draw a circle with radius 1 centimeter, and inside that we have to draw a right angle triangle with angle theta. Since hypotenuse is 1, so the adjacent will be r cos theta and the height will be, or opposite will be, r sin theta. If theta is equals to 0 degree, then this will move down and r sin theta will be 0 and r cos theta will coincide over the radius, which is 1. That is why sin at 0 degree is 0 and cos at 0 degree is 1. If theta becomes 90 degree, then it will move up here. So r cos theta will be 0 and r sin theta will coincide over the radius, which is 1. So sin 90 degree will be 1 and cos 90 degree will be 0. In this way we derive sin 0 degree, cos 0 degree, sin 90 degree, cos 90 degree. We can find tan theta, tan 0 degree as sin 0 degree by cos 0 degree, and tan 90 degree as sin 90 degree by cos 90 degree. Next, we have complementary angles. If we take a right angle triangle with angle theta, so sum of all angles of a triangle is 180 degree. So angle R plus angle P is equals to 90 degree, because angle Q is already 90 degree. So if angle R is theta, then angle P will be 90 degree minus theta. Here you have to notice, if we take cos theta, then it will be QR by PR. If we take sin 90 degree minus theta, it will also be QR by PR. So we can say that sin 90 degree minus theta can be equals to cos theta. Similarly, cos 90 degree minus theta will be equals to sin theta, tan 90 degree minus theta equals to cot theta, cosec 90 degree minus theta equals to sec theta, sec 90 degree minus theta can be equals to cosec theta. Next we have trigonometric identities. In class 10 you will get three trigonometric identities, which are sin square theta plus cos square theta equals to 1, 1 plus tan square theta equals to sec square theta, 1 plus cot square theta is equals to cosec square theta. These are true for all values of theta. For deriving first identity, we have to use Pythagoras theorem, which states that opposite square plus adjacent square equals to hypotenuse square. Now we have to divide by hypotenuse. So we get opposite square by hypotenuse square plus adjacent square by hypotenuse square equals to hypotenuse square by hypotenuse square. So hypotenuse square and hypotenuse square will cancel out. Opposite square by hypotenuse square is sin square theta. Adjacent square by hypotenuse square is cos square theta. So sin square theta plus cos square theta equals to 1. We derive the first identity. For second identity, we are taking the first identity, which is sin square theta plus cos square theta is equals to 1. Now we have to divide the whole equation by sin square theta. So we get 1 plus cos square theta by sin square theta equals to 1 by sin square theta. Cos square theta by sin square theta can be written as cot square theta, and 1 by sin square theta is cosec square theta. So we get second identity, 1 plus cot square theta is cosec square theta. Third identity, which is tan square theta plus 1 equals to sec square theta. For this we are taking first identity, sin square theta plus cos square theta equals to 1. Now we have to divide the identity by cos square theta. So we get sin square theta by cos square theta plus 1 equals to 1 by cos square theta. Sin square theta by cos square theta is tan square theta plus 1 equals to 1 by cos square theta, which is sec square theta. So we derived the identity tan square theta plus 1 equals to sec square theta. Trigonometry rings with sides and length. Very useful in science and technology. Understanding ratios and identities helps solve many real world problems. Great job if you watched this video to the end. Now you know basic trigonometry, key ratios, special angles, values, and important identities. If this video helped you, do subscribe for more maths video. Thank you for watching and see you in the next video.